afternoon. Thanks for joining us across the fence. I'm Keith Silva. Today's topic is a bit of a tongue twister. We're talking about the Vermont Bee Lab's effort to breed better bees. To bring you this A story about bees, I'm joined by my colleague, Ben Willis. Ben, I've heard about the birds and the bees, but what's breeding bees?
That's right, Keith. So I've spent a lot of time this summer with folks from the Vermont Bee Lab at UVM. They are dedicated to the protection of pollinators through research, outreach, and education, and they're involved in some innovative research on breeding bees which are more resistant to pests and pathogens.
Ben, in our line of work, sometimes we get to wear a lot of hats. I've worn a lot of hairnets, and I've worn a lot of hard hats. To shoot this story, you get to wear more than a hat. Talk about what you had to do to report this story.
Yeah, so I had to wear a bee suit, which I've never worn before. So I think we have a clip here. I struggled a little bit to get the bee suit on, but eventually I got it figured out.
More importantly, the most important question, did you get stung?
You know, we had some close calls. I didn't get stung, but the folks from the Bee Lab will clear these frames they have to shake off the bees before they go and they run their tests. So every time they would do that, the bees would start swarming. And I think we had about 25 to 30 different frames that they had to clear. So by the end of the day, there are just bees swarming all around me in the nuke yard. So I was very concerned about getting stung. And I didn't. So the bee suit worked. I guess I was wearing it correctly.
Now, that's what I call a stinger of a story.
Let's make a beeline for Bristol to see the work of the Vermont Bee Lab and the research they're doing, which could save honeybees.
Honeybees. These remarkable creatures gracefully traverse meadows and orchards dedicated to the vital task of pollination. Yet they face an ominous threat.
Since 2006, experts have observed alarming yearly declines in honeybee colonies, a phenomenon known as colony collapse disorder. Numerous theories have emerged, pointing fingers at pesticides, parasites, diseases, habitat loss, and the consequences of climate change.
Oh, they're all in here. Nice.
Vermont Bee Lab Director Samantha Alger
And her team of technicians are in Bristol, Vermont, to work with Andrew Munkris, president of the Vermont Beekeepers Association.
Oh, there it is. The Vermont Bee Lab has been partnering with commercial beekeepers who are bee breeders to help them with their selection processes. So over time, that goal is to create bees that are more resistant to different pests and pathogens and are healthier, better honey producers, better at overwintering.
For this research, Samantha and her team will be applying a pheromone called unhealthy brood odor, or UBO.
This innovative research could help breed bees more resistant to the varroa mite.
Pretty much every beekeeper is going to agree that the varroa mite is the #1 enemy of the honeybee. It's not a pest that's native to the honeybee. It started on another species and jumped. And so the honeybee has very few defenses against it. So if we can breed in this hygienic behavior and create some resistance in the honeybee population in general, or at large, that would be huge.
UBO is a synthetic hormone, which works by mimicking the pheromone released from bees suffering from a varroa mite infestation. It triggers a response in bee colonies and can reveal to the scientists which colonies are more pest resistant.
We know that disease and pests and pathogens aren't the only threat that bees are experiencing, but it's a big one, and these things kind of act really good to know. Synergistically, right? Like if bees are sicker because the varroa mites are preying on them, then their immune systems are impacted, and any pesticides they are exposed to or forage deficiencies, it just all gets compounded. What we're going to do at this makeshift table is this is where we're actually going to be applying the synthetic pheromone, the UBO mixture, using this. The beekeepers are going to be going through the nucleus colonies, finding a frame of mostly capped brood and bringing it over to us. We're going to spray it onto the frame, and then we're going to put the frame back into the hive, and then we're going to go back into that hive 2 hours later to see how well the bees sense this pheromone and hopefully there'll be a lot of cheering when we go back and check to see how well they performed.
For the next 2 hours, Samantha and her team get to work. They use a small collar to meticulously apply a tiny amount of UBO to a specific part of each frame, until they have sprayed a frame from every hive in the nuke yard.
The theory is that the more hygienic bees will react to the smell of this pheromone when it is sprayed onto pupa in the colony.
So some colonies of bees demonstrate hygienic behavior, which means that they will actually clean off or groom off the mites that are on the bees, and those are the ones we want to be breeding from so that we can populate our operation and other operations with bees that have a natural defense in this hygienic behavior against the varroa mite.
This move to work more closely with commercial bee breeders is something new for UVM's Bee Lab.
Our diagnostic lab that we've been running for a number of years now has been largely focused on helping hobbyist beekeepers that are interested in learning about the levels of pests and pathogens in their hives. But what we notice is that it is largely just the hobbyists who are using that service and not so much the commercial beekeepers or the sideliners. And so the Bee Lab thought that it would be cool if we started to work more closely with commercial beekeepers, particularly bee producers, to help better select for bees that are more resistant to the pests and pathogens, because the bee producers are the ones that are supplying all the bees to the hobbyists. And so it'd be really starting at the source of the genetics.
Today's innovative approach, using UBO to aid bee breeders, was developed by Dr. Carol Wagner at the University of North Carolina, Greensboro.
I think as a grad student, Kara discovered that the brood, when it's diseased or infected, it emits pheromones to tell the sister bees, hey, I'm sick. And so then she spent the next 10 years or so figuring out how to synthesize it. Kara just got completely inundated when she started to announce this stuff. Bee breeders are like, thinking this could be, I don't know if it is the magic bullet, but beekeepers are thinking that this is really promising for their breeding programs.
This is, kind of cutting edge. There's a very much, there's a test with much lower sensitivity where you use liquid nitrogen to freeze kill the brood, and you leave it for 24 to 48 hours and you come back. But there, it's not actually mimicking what's happening in nature because you're actually killing the brood, and so you're only finding colonies that are hygienic enough to remove actually dead brood. And what we're looking for is much more sensitive than that. We're looking for colonies that are hygienic enough to be removing parasitized brood that has the mites on it.
After each frame is sprayed with UBO, it is returned to the hive, and the scientists wait to see if the colony will respond.
At the 2-hour mark, we're going to pull that frame again, and we're going to place the collar back on the same location where we sprayed the pheromone and take an after photo. And with any luck, many of these hives will have started to detect this synthetic pheromone that says that the brood is unhealthy in one way or another, and the bees will have started to uncap that brood.
As the 2-hour window drew to a close, the scientists counted down as the final minute approached.
We got 1 minute.
Okay. You ready?
I'm ready. I don't know about you. I'm ready.
He's ready.
He's ready.
No, not very exciting.
Oh, well.
It will take years to consistently breed in these traits, so it's possible we will not see any hygienic activity today.
Well,
Looks like
No.
another dud. There you go.
I'll look again.
Looks like maybe they uncapped one.
But then, Bee Lab tech Sydney Miller
spots a promising sign.
This is where they've chewed open capping, so you can see pupa in there that are developing. So typically they would be closed like this. But the bees have gone in to inspect because they smell like they're diseased because we sprayed the pheromone on there. So they've actually not only uncapped the wax, but they've started to chew out those pupa. So they were pretty aggressive about it. It doesn't look like they uncapped all of them, but we'll see when we do data analysis what that percentage is.
Then we saw something truly stunning. The bees not only removed the wax cap to investigate the area sprayed with UBO, but we witnessed them entering a cell and removing a pupa they believe is infected with varroa mites.
Most of the results at this point are pretty preliminary. However, I was on a Zoom presentation with David Tarpey, who's a national queen expert, and a couple of the other queen breeders on there were very interested in this UBO. And when I shared that we were participating with UVM in this continuing research project, they were extremely interested. So among the commercial beekeeping community, there's a lot of interest and hope that this might be a much more sensitive selection process for hygienic behavior than we've had in the past.
The journey may be long, but the rewards could be sweet as these scientists work together to ensure a thriving and sustainable future for honeybees. In Bristol, Vermont, I'm Ben Willis with Across the Fence.
To learn more about the research going on at the Vermont Bee Lab, visit vermontbeelab.com. There you'll find information about their ongoing research and education programs.
And that's the buzz from Across the Fence today. My thanks to everyone here at WCX who make this program possible. And as always, thank you for stopping by Across the Fence.